Good morning. Good old indices. I've actually been reading up on a lot of this online and watching some very informational YouTube videos. If I can put that in the comments, I'll provide a really good link of a series of videos that goes through these exact topics, and it's pretty powerful, I gotta say. Anywho, on to what is being attacked on here. Now, the way that this can happen is probably by, it is by properties of how the Dirac-delta function works, which you probably already know its properties. And if you don't, then here is the properties with it. So long as indices match, so the indices I and j, those are just filler indices. They can be any two that you want to be. They can be anything that you want to be if you directly multiply a Dirac-delta on, but if it per se comes from those partial derivatives right there, the partial xl over partial xi, then it has to be L in the top, I in the bottom for its indexes, but that's just brute handwork stuff. Yeah. Fun times in that regard. Anyway, with this one, whenever the indices would match, it only pops out a 1. Otherwise, if it's a mismatching index, it'll pop out a 0. So say it tried all the different indices that are available to it to the letter right beside it. So it's got choices of L and M as the indices. Well, if we input L to that, L and L would match. You make a 1. If you tried A, M, M, well, that doesn't match. Output is 0. So this Dirac-delta function is almost a way to be able to rewrite the indices on your coefficients there with it to a set of new indices, because if these match, the L's match to an I, then it pops out something that you can actually work with. And if it didn't, then it would pop out a 0, which kind of has its own roots in the identity matrix, like whenever you're working with that old thing, the capital I, because whenever it matched its indices, it made a 1. Didn't match, it made 0s, and so on. So it's almost like an absorption from the identity. That's what like the Dirac-delta is. So it's a nice way to be able to then rewrite your indices so that you can further work on and get further and further forward to the proof that you need with the aij plus aji indices coefficients with those indices equal to 0. If there are any further questions, we can, if you'd like to make any sessions with me, that would be great. We could maybe go through together some of the videos that I was explaining about. They go much farther in depth and into some example problems and proofs than I am able to, at least on my own. And yeah, I hope this helped. I hope that makes an understanding of how this equation turned to that one of the indices rewriting due to the Dirac-delta and matching indexes to turn it from an L to an I and a M to an I. I hope you have a good day. Thank you. Bye-bye.